Let's compare bare metal, virtual machines, and containers. Let's start with bare metals. Bare metals generally means a physical machine, okay, some server. This is your hardware, so operating system, and some application is running on this bare metal. So the term generally defines a physical machine running a single tenant application, meaning that the single application can utilize all the hardware along with the OS. So bare metals are ideal for processing large amounts of data. They are super stable and provide high performance because one application is utilizing all the hardware. But the downside is it's expensive. Now consider the second form factor, virtual machines. Here you have the hardware, then the OS layer. We call this host OS. Then we have a component called hypervisor, which is going to virtualize and create the VMs. And here you have your virtual machine, the operating system. We call this guest operating system. This is a host operating system. Top of this, you deploy some binaries or dependencies, right? And then you have your application here. So in case of VMs, hypervisor is virtually sharing this hardware and creating a VM. With hypervisor, we can set a fixed amount of hardware, like say for example, we can set 2 gigs of RAM, 60 gigs of disk space, and 2 core CPU. Like that, we can allocate to that virtual machine. Now if you compare virtual machine versus bare metal, in bare metals you have single application. In case of VMs, you can create multiple copy of this application or many other applications you can deploy like this. But again, you have to fix some sources. Okay. So depending on your hardware, you can scale your application. Now consider containers. Here you have the hardware layer and then operating system. Here you have a component called container engine. This container engine will package your application with some libraries and dependencies. As you can see that there is no operating system here and no hypervisor, making this lightweight. And if you want to scale your application, you are not duplicating the OS. So the advantage here compared to virtual machine is that containers are lightweight. So this brings us the agile advantages like portability, scalability, and suitable for cloud native applications. Also, as you scale here, the hardware utilization goes up. In case of containers, hardware utilization goes up, but not to an extent of virtual machine. And the second difference is, suppose this virtual machine is stopped, the resources allocated are fixed and that cannot be utilized by other VMs. In case of containers, if you stop a container, the resources can be utilized by the other containers. So that is the advantage. Now let's see what options we have for managing the containers, what tools are available. We have tools like Kubernetes for managing containers, Apache Mesos, Docker Swarm, etc. And for container runtime or container engines, We have Docker, Podman, Containerd, Cryo, and many others. Now to summarize, this is what we have. In case of bare metals, it's one tenant per physical machine. Virtual machines, you can create many by sharing the hardware using hypervisor. But again, these virtual machines are set to fixed amount of hardware. In case of containers, they are meant to lightweight. It's easy to scale, portability is easier, and meant for cloud native applications. I hope that is clear. Thank you.